today we'll be learning how to find out the solution of homogeneous equation. And in the last lecture we had done a first step where the system was having the trivial solution. That means the value of the variable x, y and z was 0. Now today we will be doing where we will be having infinite solution in the system of homogeneous equation. Let us take one example and we will learn how to get that solution. Let us take the question. First equation take as x plus 3y minus 2z. That is equal to 0. Second equation is 2x minus y plus 4z is equal to 0. And third equation is x minus 11y plus 14z is equal to 0. In matrix form, we can write this as it is going to be 1, 2, 1, 3, minus 1, minus 11, and 2, 4, and 14. Then we have x, y, and z is equal to 0, 0, and 0. Now we are having this 1, and this is the below the diagonal line, and these three elements which are just below the diagonal, we have to make that as a 0. Now for that we will be doing operation r2 minus 2 times of r1, because this is 2, and if we subtract, if this is 2, and if we subtract 2 times of 1, it will become 0. And here we are having the same number as this one, so we will be just subtracting r3 minus r1. Now we are changing row number 2 and row number 3. Row number 1 will remain as it is. So let us copy the row number 1 first. 1, 3, 2, x, y and z, and here we are having 0. So we will be doing rough work. Let us create some rough space for that on the right side. Okay, now the operation is r2 minus 2 times of r1. We will write r2 elements. R2 elements are 2, minus 1, 4 and 0. 2 times of r1, that are this is r1 row. We will be multiplying this row by 2. It will become 2, 6, 4 and 0. As we are subtracting, sign will change. So 2 minus 2 is 0, 1 minus 6, minus 1 minus 6, that is minus 7. This is 0 and this is 0. So we got the second row as 0, minus 7, 0 and 1 minute, I think somewhere is the mistake here. This is minus 2. Yeah. So this will be minus 4 and this will become plus 4. So this is going to be 8. So this element is going to be 8. Now here we'll be doing the operation on the third row, that is r3 minus r1. R3 elements are 1, minus 11, 14 and 0. And r1 elements are we are having 1, 3, minus 2 and 0. We'll be changing the sign. So 1 minus 1 is 0, minus 11 minus 3 is minus 14, and 14 plus 2 is 16 and 0. So we got the elements as here 0, minus 14 and 16. Here this one was 0 and this is also 0. Now again we will draw the line below the diagonal. Still there is one number which is not 0. We will be making that 0 with the help of number present at second row, second column position. So we have r3, both the numbers are having same sign, so we will be subtracting 2 times of r2. both will become 14 minus 14, and when we subtract that will become 0. Let us copy the row number 1 and 2 because we are doing the operation in row number 3, so 1 and 2 will remain same. We will copy paste that. 1 3 minus 2 x, y and z, and here we have 0. Second row will remain as it is, 0 minus 7 8, and here we have 0. Now we are doing the operation as R3 minus 2 times of R2. R3 elements are 0 minus 14 16 and 0. So here 2 times of R2, that is 0, this is 0, 0, 7 2s are 14 with the minus sign, 8 2s are 16, and then 0 2s are 0. We have to subtract, sign will change, and 0 minus 0 is 0, 14 minus 14 plus 14 will become 0, 16 minus 16 will become 0, and this will remain 0. So we got the last row as 0 row. Now this is in echelon form now. What is the rank of this? From here we can predict this rank. Row 1, that is not equal to 0. Row 2, that is also not equal to 0 because there are two elements minus 7 and 8. And row 3, all the elements are 0. That means row 3, R3 is equal to 0 row. Now from this we can predict what is going to be the rank. There are two non-zero rows, so rank of A, that is a coefficient matrix, that is equal to 2. Number of variables are 3 because we have x, y and z. Now these two numbers are not same. The rank of A is not equal to the number of variables. Since rank of A is not equal to number of variables, therefore there will be infinite solution. We say this one many of the time, rank of A is less than the number of variables. Sometimes we write not equal to, sometimes we write as a less than. So either you can use this sign, otherwise this sign, whatever you like. There will be infinite solution. Now the difference in that, number of variables are 3, rank is 2. 3 minus 2, what is that difference? That is 1. Therefore we have to pass, we have to take value of one variable from our side. That we take an arbitrary value, that is arbitrary value. Now if we look at the equations here, we write that in equation form. In equation form, first equation will be from the equation number 1, row number 1, 1 3 minus 2. The coefficients are 1 3 minus 2, that is x, 1 3 plus 3y minus 2z is equal to 0. Now go back to that last step here. Here x is 0, y is minus 7, 8, z is 8. So minus 7y plus 8z minus 7y plus 8z is equal to 0. Third row was a totally 0, so we cannot write that equation because all the coefficients are 0. Now we will take this as a first, this as a second equation. Now from here, if we see this one, 8z is equal to 7y, this minus 7 will go to the right side, will become positive. So what is z here? Yeah, we can take the value of y or we can take the value of z. Anyway, from here if we take what is going to be the value of y from here, value of z. So here if we take z on the left side, it is going to be 7 upon 8y. Is it clear? Here this is not there. We got the value of z in terms of y. let y is equal to t. So z is equal to, if we take y is equal to t, so z will be 7 upon 8t. Now we got the value of y, we have got the value of z. Always remember here, as we have shown that 3 minus 2, that is 1, it clearly indicates that we have to take the value of one variable from our side. So we have taken the arbitrary value of y as t. See, from here, this equation, we got the z in terms of y. Z is equal to 7 upon 8y. So what I did, I have taken y is equal to t, substitute y is equal to t here. So it will be 7t upon 8. So we got the answer for z. Substituting value of y and z in equation number 1. So what we are going to get is x plus 3 into y we have taken as t, minus 2 into z is equal to 7t upon 8 is equal to 0. Now this is x plus 3t and 2 1 ja 2 4 ja, it will get cancelled. So we have minus 7t upon 4 is equal to 0. We will be taking all the t terms on the right side. First we will be taking LCM. X plus, we will be taking LCM with this one, 4 3 is 12, 12 minus 7, that is 5. This is going to be 5t upon 4 is equal to 0. Now so x is equal to minus 5t upon 4. So we got, therefore x is equal to minus 5t upon 4, y is equal to t, and z is equal to, we have got 7t upon 8. Now, but just by taking the different values of t, we can have an infinite solution.